Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Hello everyone, hope you are all doing fine. In this video, I will be discussing interview questions and answers in chemical engineering heat transfer part 4. This video is prepared in response to requests from viewers. Hope it will be useful to you all. I would appreciate if you subscribe to the channel. It will motivate us to produce free knowledgeable content for you. So subscribe now before you forget. For every question, you are given 20 seconds to think about your answer. Then the answer will appear. Check your answer is correct. Wherever required, detailed explanation is given. Question number 16. In a Shelved heat exchanger, which type of tube pitch is selected to facilitate shell side cleaning in the case of fouling fluids flowing on the shell side? Your time starts now. Your time is up. The answer. Square pitch is selected for easy cleaning of outer surface of the tubes on the shell side. Usually, fouling fluid such as cooling water is allowed to flow on the tube side and the non-fouling fluid on the shell side. In case both hot and cold streams have fouling tendency, the fluid with less fouling characteristics is routed to the shell side. In that case, tube pitch should be such that it makes access to the external tube surface on the shell side easier so that the surface can be cleaned. The square and triangular pitch patterns are illustrated in this figure. The square pattern has a lower shell side pressure drop as compared to the triangular pitch. The square pitch layout will have the lower heat transfer coefficient as compared to the triangular pitch. Question number 17. What is the purpose of insulation? What are some of the commonly used insulation material for A. Cold refrigerant lines, B. Steam lines, C. Fired heater or furnaces, and D. Liquid nitrogen and liquefied natural gas storage? Your time starts now. Your time is up. The answer. Insulation is used to prevent heat loss or gain in piping and equipment in process industries and commercial buildings. This is the primary purpose which arises from economic considerations. Other purposes include to prevent moisture condensation and corrosion, to protect the operating personnel against hot and cold burn by accidental contact. Insulation materials are poor conductor of heat and has extremely low thermal conductivity. What is the thickness of the insulation required? Is it the same for all applications? The thickness depends on the temperature of the fluid in the pipe and the type of insulation material. For cold refrigerant lines, the insulation used are mineral wool, expanded polystyrene, and polyurethane foam. Material used depends on the purpose. For protecting the pipelines against atmospheric corrosion due to condensations below 30 degrees centigrade, mineral wool is used, being low cost. For cold preservation, polyurethane foam or polystyrene can be used. For steam lines from 90 to 325 degrees centigrade, the insulations used are mineral wool, asbestos fiber, glass wool. Fired heater and furnaces operate at high temperature of the order of 1200 to 1400 degrees centigrade. Refractory is a material that is used as insulating material in the fired heater and industrial furnaces. They are capable of withstanding high temperatures, hot gases, corrosive environment, usually experienced in furnaces, incinerators, and boilers. There are several types of refractories. The most common types are castable and ceramic fibers. The main constituents are SiO2 and Al2O3. Shown in this figure is a fired heater. The furnace walls are insulated with refractory bricks. They have extremely low thermal conductivity, which is desirable for insulation. Refractory seals the heater casing from excessive temperature. It is designed to reduce the casing metal temperature to roughly 80 degrees centigrade. Liquid nitrogen and LNG are stored at cryogenic temperatures. Liquid nitrogen and LNG have a normal boiling point of minus 196 degrees centigrade and minus 160 degrees centigrade respectively. Although used in gaseous state, nitrogen and LNG are commonly transported as a liquid, affording cost-effective way of providing product supply. They are stored in double-walled storage tanks, where the inner container contains the liquid and the outer one contains the insulation material. Perlite powder is used as the insulation material. Perlite has extremely low thermal conductivity in the range of 0.06 watts per meter Kelvin. Usually, evacuated perlite is used rather than normal perlite, which has superior insulating properties needed for cryogenic services. Question number 18. What are compact heat exchangers? What are the main characteristics of compact heat exchangers? Your time starts now. Your time is up. The answer. Plate heat exchangers are called compact heat exchangers. They include plate fin heat exchangers, two fin heat exchangers, and plate and frame heat exchangers. The main characteristics of compact heat exchangers is a high heat transfer surface area per unit volume of the heat exchanger. A compact heat exchanger is typically defined as one having an area to volume ratio of greater than 600 to 3 into 10 to the power 4 meter squared per meter cube. Shelved heat exchangers typically have area per unit cubic meter of installed volume in the range of 60 to 600 square meter. Shown in the figure are plate fin heat exchanger and two fin heat exchanger. Question number 19. What is the function of baffles on the shell side in a shell and tip heat exchanger? Your time starts now. Your time is up. The answer. The function of the baffles in a shell and tube heat exchanger is to direct the flow across the tube bundle as well as to support the tubes from sagging and possible vibration. Note that the presence of baffles in the shell side of the exchangers increases the pressure drop on the shell side. However, the advantage of better mixing and turbulence more than offset the pressure drop disadvantage. Baffles increase the velocity and are treated as design variable to increase the velocity to obtain higher heat transfer coefficient. Illustrated in this figure is the baffle arrangement in the shell and tube heat exchanger. The fluid on the shell side enters at the top and flows across the tube bundle, deflected by the baffles located along the length of the heat exchanger as shown. The number of baffles in a given shell length and the type of baffle are the heat exchanger design parameters. Question number 20. What is shell equivalent diameter and where it is used? Your time starts now. Your time is up. The answer. Shell equivalent diameter is the diameter of fluid passage on the shell side of a shell and tube heat exchanger. It is also called hydraulic diameter and is denoted by dE. It is used in the determination of shell side heat transfer coefficient Hs. The shell equivalent diameter depends on the type of tube pitch used in the heat exchanger. It is a function of tube pitch and tube outside diameter. Before we move on, I would like to make a call to my dear viewers. Your SPEC e-learn channel is one-stop learning and skill development destination for your career needs. Get instant access to useful career-oriented subjects and become knowledgeable and competent. So do not forget to subscribe. Please press the subscribe button now. Question number 21. What is Lmtd? What is its usefulness in the analysis of heat exchangers? How do you apply the Lmtd for a shell and tube heat exchanger? What is Lmtd for a reboiler, assuming only the latent heat is used in the heat transfer? Your time starts now. Your time is up. The answer. Lmtd is a way of approximating the average delta T between the hot side and cold side throughout an exchanger. In the heat exchangers, during heating or cooling, the temperature changes along the length as the fluid moves. Heat transfer rate is determined by the temperature difference between the hot fluid and cold fluid at any point in the heat exchanger. Since the temperature along the length of the heat exchanger is changing, the heat transfer rate is also changing as the fluid moves. Hence, to determine the heat transfer in a given heat exchanger, the average temperature difference Lmtd is used. How to apply the Lmtd for a shell and tube heat exchanger? A true countercurrent flow is obtained only in the double pipe heat exchanger. To account for the difference in flow pattern, cross flow, the actual Lmtd needs to be corrected. A true counter current flow is illustrated in this figure. If heat exchangers other than double pipe heat exchangers are used, heat transfer is determined by using correction factor F applied to the counterflow double pipe heat exchanger. The correction factor F depends on the geometry of the heat exchanger and inlet-outlet temperatures of the hot and cold fuel streams. Coming to the last part of the question, in the reboiler, phase change is occurring on the hot side and the cold side of the heat exchanger. It is given that only latent heat is transferred on both sides. During the phase change, the temperature remains constant, as shown in the temperature profile in this figure. The temperature difference between the hot side and cold side is taken as Lmtd for the reboiler. So, the delta T equal to the Lmtd, which is equal to Th minus Tc. Question number 22. How is heat transfer by radiation different from conduction and convection? Name the law which governs the radiation. How will you increase the heat transfer by radiation by a surface? Your time starts now. Your time is up. The answer. Radiation differs from conduction and convection in the sense that it does not require a medium to occur. Heat transfer by radiation occurs by electromagnetic waves which travel at the speed of light. The radiation energy emitted by black body is determined from the Stefan-Boltzmann law. EB equal to sigma times T to the power 4, where EB is the radiation energy emitted by black body per unit time per unit surface area. Sigma equal to 5.67 into 10 to the power minus 8, and T is the absolute temperature of the surface in Kelvin. Radiation emitted by a surface is determined from emissivity. Emissivity is the property of the material and is defined as a ratio of energy emitted by the real surface to that emitted by the black body at the same temperature. So emissivity epsilon equal to E by EB. So E is equal to emissivity times EB. Thus, the radiation can be increased by increasing the emissivity of the surface. Question number 23. A process plant has several cooling water heat exchangers, that is, heat exchanger using cooling water as utility in the process network. The cooling water flow rate to each of the cooler is different due to varying heat loads. What is your design consideration in designing heat exchangers for such a system? Your time starts now. Your time is up. The answer. A process network with the 3 heat exchangers with cooling water as utility is shown in this figure. The heat exchangers draw in cooling water from the same cooling water supply header and return the cooling water to the same return header. The design consideration is that all the heat exchangers should be designed with equal pressure drop for the cooling water side. If the design pressure drop varies from heat exchanger to heat exchanger, the resulting cooling water flow to a given heat exchanger may not be equal to that specified on the heat exchanger data sheet. Some coolers will get more and some will get less flow. A large cooling water consuming heat exchanger at low design pressure drop will take larger share of water from other coolers at higher pressure drop. By designing all the coolers at the same pressure drop, you can prevent this improper distribution from happening. This approach will avoid poor thermal performance due to low cooling water velocity. Question number 24. What is the difference between vaporizer and reboiler? Your time starts now. Your time is up. The answer. In reboiler, only a fraction of the liquid entering is vaporized, whereas in vaporizer, all the feed that is entering is vaporized. Reboiler is used in distillation system at the bottom of the column to supply vapor reflux to the column. The feed to reboiler is internal fluid from the distillation column. The feed to the vaporizer is taken from an external source, for example, raw material or feed storage tank. An example of vaporizer is an equipment used for supplying vapor feed to reactors. Illustrated in the figures below are vaporizer and reboiler. In both equipment, usually the latent heat is added and vapor is generated. That is to say, the vapor is at the saturation temperature corresponding to the system pressure. Question number 25. Give two examples where heat transfer or convection is not possible. Your time starts now. The two examples are solids and vacuum. For heat transfer by convection to take place, there must be free movement of fluid molecules. Molecules in solids are fixed and cannot move freely. Vacuum. Convection heat transfer cannot take place in vacuum because there are no particles of any kind in vacuum which can move and transfer the heat. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.